السلام عليكم رب اشرح لي صدري ويسر لي امري واحلل عقدة من لساني يفقهوا قولي رب زدني علما. We have been discussing about engineering statics for throughout the semester. We are now closing our subjects, but we have few articles to discuss. Among the few articles is the friction. Now, in the last few chapters, we have developed certain concepts. We knew the standard concept of entire engineering mechanics when statics is number 1, sum of all forces equals to 0. Number 2, sum of all moments equal to 0. We started from a standard 2-dimensional system, Cartesian system, and then we went to 3-dimensional Cartesian system. Among the numericals, you face certain problems related to normal tangential coordinate system, coordinates, and polar coordinates. But normal tangential and polar coordinates are again 2-dimensional systems. We developed these concepts up till chapter 2. In chapter 3, we talked about certain joints in 2-dimensional systems and 3-dimensional systems, and we talked about the reaction of these joints. In chapter 4, we talk about trusses, how big trusses are formed, and how to analyze these trusses by understanding 2 different types of analysis technique, that is called by method solving trusses by the method of joints or solving trusses by method of sections, in which we went from 2-dimensional systems to 3-dimensional systems or space truss. In chapter 5, we talked about energies, work potential systems, and from there we defined something called work. So question is, if everything is at static, why do we need work? And we went through it quite detailed. Not everything can be defined in terms of forces. Sometimes system has to be defined through energy, especially when we're talking about mechanical frames, mechanical structures. So the most basic of the structure is the plier. When you hold a nut in your hand through a plier and want to tighten it, but in order to hold it, you grip across your plier. Now, once it has held the nut, everything, all the forces acts in equilibrium. But the question is, if they are in equilibrium to begin with, how do you analyze how much energy is being consumed in holding that nut? So we came across the concept of virtual work analysis. From there, we talk about certain other elements such as cables, beams, external and internal effects on the beams, and then we talk about fluid. Now we have talked all of these elements. One thing is still missing in our day-to-day analysis is the losses. How come when we introduce certain amount of force and based on the governing equations we have studied so far, the sum of forces don't sum equal to 0, but there is some losses. We need to apply some additional forces. So where do these losses come from? And so one of the major field that discuss these losses is friction. So in this chapter, we are going to talk about frictional losses. But before frictional losses, we need to understand what is friction. How do we came to a conclusion there is such thing is called friction? So in order to understand this thing, we need to understand the basic mechanics of friction and types of friction. So the researchers, they came to find out there are, so we are still running the time. Let me select a pen. There you go. There are tangential forces, like, okay, this is the basic definition of friction. Frictional force, you have to understand, as you have studied in high school and in your engineering physics, it is a phenomenon of the surface irregularity. It is generated due to surface irregularities. When 2 surfaces comes in contact, when you place one, such as your mobile phone on the tabletop, the 2 surfaces, the bottom of your mobile phone and the contact point or the contact area that is making with the tabletop, the 2 surfaces, when it comes in contact, they do not come at 100% contact. As you all know, at a microscopic level, these surfaces comes in contact over certain areas such as um, irregularities of the surfaces, the peaks and the troughs that comes in contact, and they interlock with each other. But the force is, because mg is acting downward, the entire force is not acting downward. There is certain tangential components acting on it, because when the two surfaces comes in contact, for instance, one irregularity comes in contact this way, the other comes in contact and moves this way, the action reaction force is at a specific contact point or the tangent of the two curves, hence tangential forces. Now, this is a basic definition. So the question arises, is a friction a good thing or a bad thing? Friction is a good thing and a bad thing. It is considered a friend and a foe, but depends on the scenarios. Friction is a friend when we are walking on the surface. Friction is a friend when our car is taking a turn or across the road. Friction is a friend that enables us to drive our vehicles. Friction is a friend when we transmit energy from the engine to the wheels, because we use this friction on tire treads, we use this friction on clutch plates, and friction is also our friend when we need to apply brakes. All these places friction is important, and so many places where friction is very important, such as belt drives, such as screws, wedges, so on and so forth. But friction is also a problem, such as bearings, jet bearings, journal bearings, where friction is problem when we are talking about fluid frictions, aerodynamic frictions, atmospheric frictions. So many places where friction increases energy losses. It creates problem for our system to overtake the or overcome the losses generated by the friction, such as bearings. Now let's talk about bearings. When roller bearings start rolling, the surface in contact tend to slip. This slip causes surface friction, and in return, a small wear and tear starts to take place. These wear and tear eventually grows up, causing fatigues, creep, and as a result, there is a sudden failure of the due to this friction. One of the most common type of failure most of the motorcyclists see is the failure of their clutch wire or brake wire. Why? Because the outer layer of the cover is basically made of steel. It has internal steel wiring, and internal cable is also steel. The two surfaces comes the friction, they rub across each other. As a result, over the period of time, the inner core or the wire, the cable surface tends to loosen up. Despite you apply the clutch so often, you have a fatigue life of steel very high. As a result, the amount of force you apply is not significant to break the cable, but it is that friction that causes a gradual erosion of the cable. As a result, it snaps. You also see the friction losses most of the time on your vehicle when you see the bearing has just gone apart, and most common time you see the friction to be doing its most of the job is when you have to replace your clutch plate. It's an expensive piece of equipment for your automobile. You need it because you like this friction, but this friction has a negative impact. It damages the surfaces. Now, what type of friction we are going to study in this chapter? We have so many types of frictions, but we are only considered dry friction, that is surface to surface contact friction, and in this we are going to focus on static and kinetic friction. Now, as you have seen this thing, you can definitely go through this part. We are going to talk about the mechanics of a dry friction, how it works. Like I have said, there are certain surface irregularities, and these irregularities, when the two surfaces comes in contact, this surface and this surface, like the two surfaces comes in contact, these bumps or irregularities comes in contact. As you can see, the reaction R1, R2 and R3 are not normal to the surface. In fact, they are tangential to the surface. As a result, you have tangential force. So how do you define R? R is defined as the reaction force F, which is equal and opposite to P, and is in fact a response to normal force generated by the weight of the block. So we have a question. What is coefficient of friction? Coefficient of friction is in fact perpendicular over base. That is, alpha is defined as coefficient of friction as tan of alpha. Sorry, pardon me, tan alpha is defined as µs. So before we look at this thing, we also need to understand how do you differentiate between a static friction and a kinetic friction. A static friction talks about when the blocks are resting over each other and interlock to each other, and you apply a gradual increment of forces. As a result, all of a sudden, the object passes through the peak value of the hump or the surface irregularity and starts to move. The moment it climbs that hilltop, that is the place where you have the maximum resistance within the two surfaces. Until that point, your object is in static position. Once it starts moving, your kinetic friction tends to go drop suddenly. Now you have to understand, the more speed you increase, the faster you move. The faster you move, the less normal force tends to act on it. As a result, your kinetic friction can even go slower. In order to increase kinetic friction, you can introduce a thin film of lubricant. So it will reduce the overall the static friction coefficient, but also will reduce the kinetic friction. So these things are the basic mechanics of the surface friction. Now, we are going to talk about static friction. You have to understand, in this term, the µs is termed as the maximum value. As you can see, you have to cross this value, and this peak is considered µs. Otherwise, the moment you start applying the force, this µs, this region, does not mean there is friction going on. It can also mean that the mass or the inertial property of the mass is also coming into play. As a result, you cannot move, which does not signify your problem. Which does not simplify the problem. Now, so in order to analyze this thing or understand this thing, we say the only place we have µs, or we can find the value of µs, is the maximum value at the peak of it. Now, let's go further. So mu k is, what is mu k? Mu k is generally less than µs, we know that. But we also know that mu k can only be found when the object is in motion or it is moving with a constant velocity. This means it is in a dynamic equilibrium. After that, we have to find what is coefficient or angle, frictional angles. You have to understand frictional angles are an important part of our analysis. Why? Number one, mu k, you can say the two angles. It's very, very hot today, and I tend to big sweat. I don't like heat very much. So the two angles, you have to understand the two angles. The two angles can be defined as two cones. Why the two cones? If you take the maximum value of the angle at which the static coefficient tends to achieve, or the coefficient of static friction, that would be the maximum value. To take the tan inverse of that, you will find the angle that is called phi s. The phi s is just an angle from the central axis, right here. You drop this central axis, and this angle, the bigger one, is your phi s. And when you take this surface and you revolve around this axis, you will get a 2 phi s angle or cone. Now, why is this cone important? You have to understand, your coefficient will only vary when you are in a static condition between mu k and mu s till this region. Beyond this region, everything is in motion. That is within phi k region of the cone, everything is in kinetic system. Everything is in motion. This means the lower the value of this angle, this means lower the angle of F, or increase the normal force and reduce the you can say perpendicular force, the surface to move, the force required to move the object. Your phi is going to drop, but it is also going to increase your static friction. Sometimes this is important. We need to use this thing in order to increase the angle. Now this thing can be introduced, or we can learn from this thing is we can reduce the surface irregularity, and we can create a very good surface finish in order to achieve lower angles, or angles of the body angles within 5K region. So these angles help us analyze only the behavior of the system. Now you have to understand these angles are also important in aerodynamics, especially when we're talking about gas friction, air friction. Since this topic or this book does not cover this thing, it is just there to show you how this thing works. But you can assume this thing in terms of projectiles, where two surfaces come in contact and they move. So how do you define the angle of your surface area or the surface finishing? These angles helps you analyze these physical properties. So what are the surfaces factors that affect the friction? You have to understand, if you see, in your cars, when you leave something, let's say nut and a bolt, in rain for a long time, rust tends to develop. A metal oxide film is developed. That metal oxide film tends to weld things. Now it is going to increase the friction, but on the other hand, if you remove these metal oxides, it can reduce the friction. Number two, these metal oxides are sometimes helpful, such as aluminium oxide or thin film oxides, such as zinc oxides. They thin film surface coatings that cause minimum friction. What happens is these micro or nano level surface coatings, they tend to fit in the surface or the frictional surface or humps of the surface. As a result, they create minimum surface resistance, which cause it to move faster and hence reducing the friction. Now you can use these lubrications in engine oil, such as engine oil. You can use these particles in engine to reduce the friction, and this is where most of the work is being done in frictions, such as engine or tribology is introduced to introduce less friction in the engine surface, to create more efficient assist engines. As you know, the modern sports car engines, they have low tolerances or low clearances between cylinder and piston. In order to remove much of the heat, what they introduce is special oil, special lubricants that has the capacity to take away heat faster and creates a very thin film to reduce friction. Now, you have also to understand how the forces tend to work. F max is equal to mu s. If it is less, you have to understand the limiting friction value and the slippage value. So you know, uh, if F is less than the mu s, then you have no slippage. It is static. So you have the tendency to, let me put it this way. There is a tendency of motion. The mu s can generate almost no motion, but the body in motion will tend to move in motion. And mu s, the first condition, if we say the F is less than mu s, this means the coefficient of friction will not hold, because you don't know if this is the limiting value of mu s. And when you introduce mu s, you will get wrong answers. Then if F is equal to mu s and you get that this is the maximum force at which it is about at the verge of slippage, only then you can find the actual value of mu s. Now if F is greater than F max, then you have to understand this thing, that the force or the object is in motion and mu s is no longer going to be applied. In fact, you have to calculate for mu k. These are the certain problems you have to understand. Now we are going to go through the problems, and that will be in next part of the lecture. Thank you.